Okay, let's work another example. So this one says, suppose a firm is expected to increase dividends by 20% in 1 year and by 15% the next year. After that, dividends will increase at a rate of 5% per year indefinitely. If the last dividend was $1 and the required return is 20%, what is the current price of the stock? Okay. So here we have a slightly different non-constant growth example, where we have a dividend being paid as $1, and then it's going to increase by 15%, and then it's going to increase by 20%, sorry, 20 first, and then it's only going to increase by 15%, and then it's only going to increase by 5% forever. So we kind of have 3 stages, right? We have 3 changes in G. And what we have to identify is what the true first stage is and the true second stage is. Okay. So let's start by getting all our ducks in a row, all our information from the problem down on the page. Start the timeline. Okay. So we know a few things already right off the bat. Right. The first is that the firm just paid, or the last dividend was $1. So this is D0, that's $1. Then we know that dividends are going to grow by 20%, so the growth rate will be 20% for 1 year. And then the growth rate will be 15% in the following year, and then forever after that, it will be 5%. Okay. And we know that the discount rate is 20%. Okay. So, a few things. First, let's get started by calculating some dividends. Right? So we want to know D1, and D1 is equal to D0 times 1 plus the growth rate. So $1 times 1 plus 20% gives us $1.20. And then D2 is equal to D1 times 1 plus the growth rate. So $1.20 times 1 plus 15% gives us $1.38. And then D3 is equal to D2 times 1 plus the growth rate, where D2 is $1.38 and 1 plus the growth rate now is 5% forever. And so D3 is 1.449. Okay. So that's what we have. We have D1 equals $1.20. We have D2 equals $1.38. And then we have D3, which equals 1.449. Okay. And that's all the information we need to solve the problem, really. What we have to do here, remember, is take the present value of every dividend that comes. And what the trick that we're going to need to do is, because we can't take the present value of each dividend individually forever, we're going to have to identify the place where we can use our dividend growth model to condense a whole bunch of dividends down to a single cash flow. Then we'll only have a limited number of cash flows we will be able to take the present value of one by one. And so we start with step 1, where step 1 is identify the time period where the rate changes forever. And here, of course, forever is particularly important because we have multiple rate changes. But the rate changes forever here, right? It goes 20%, 15%, and then forever after year 2, it's only going to be 5%. So year 2 is where the rate changes forever. This distinguishes the first regime from the second regime. Step 2 then is use the dividend growth model starting at that time, starting at time period 2, to aggregate all the dividends that come after into a single cash flow. Okay. So that means we're going to use, we want to do our model here at P2, right? So we want the period following, the dividend of the period following, which is D3, divided by R minus G. We calculated D3, 1.449, divided by the discount rate, which is 20%, minus the growth rate. And here, the growth rate, this is the growth rate that will continue forever. Okay. So what that effectively means is that P2 represents all the dividends that will come, right? It represents the value of all the dividends from the third dividend to infinity, right? Again, we have taken a problem that would have required us to take an infinite number of present values, right, of all these dividends, and we have condensed it to 3 cash flows: the first dividend, the second dividend, and P2, which represents everything else. So we've taken a problem that is impossible and turned it into a problem that is solvable. Now the final step, step 3, is we need the present value of all the remaining future cash flows. At time period 0, so today. Right. So if we go back to our timeline, we can write down the cash flows. We have D0, we have D1, we have D2, we have D3, we have D4, we have D5, all the way to D infinity, right? Now we need to take the present value of each of these cash flows one by one. D0 is $1, D1 is $1.20, the future value of all these. D2 is $1.38. And then D3 to infinity we have replaced with the cash flow P2, which is $9.66. Right? So we have 4 cash flows, but we don't include D0 here because this D0 is the last dividend that was paid. So this is not a future cash flow. It's only included here so that we can calculate the future cash flows, right? So make sure that you are only including future cash flows. So we only have 3 cash flows in the future that we need the present value of: D1, D2, and P2. And we can do all of that just on our calculator. Okay, so D1, right, the present value at time 0, D1 has a future value of $1.20. N is the number of years in the future, so it is 1 year in the future from time period 0. IY is the discount rate, is R, so that's 20%. Don't get this confused. This is not G, okay? Don't get this confused. Even though G is 20% in the first year IY is always R, the discount rate. And we compute our present value here and we get $1 even. D2, present value today of the second dividend. Well, the second dividend has a future value of $1.38. It happens 2 years from time period 0. IY is the discount rate, which is again still 20%. And we compute the present value of the second dividend and we get 0.9583. And then P2, the third cash flow. The present value today of the third cash flow that has a future value of 9.66. The in, this cash flow effectively happens 2 years in the future. Again, the subscript is your in. IY is the discount rate, 20%. Compute the present value of all the remainder of the dividends, and we get 6.7083. Last step is add them all together. The price is the sum of the present value of the future cash flows. So $1 plus 0.9583 plus 6.7083 is 8.67.